In today's video, we are going to talk about what are called logarithms, and we are going to be evaluating logarithms. So one thing you might want out today is that powers table from a few weeks ago, because logarithms are basically just another way to rewrite an exponential equation. And in next week's lessons, you're going to see that logarithms help us solve those equations where x is up in your exponent. So it helps us rewrite exponent equations and get it into a form where we can keep solving for x. So the definition of a logarithm, okay, with a base b, all right, we define it as let b and y be positive numbers. Okay, b is not usually 1. Okay, so the logarithm of y with base b is going to look like this. Log with like a little b, we call that a base b of y. So how I pronounce this would be pronounced log base b of y. Okay, so if I'm going to go back and forth from log to exponent form, which we're going to do in the first few examples, all right, you're going to see that log base b of y equals x. So this is my log form. So if you have log with a base of some number of another number equaling another number, I can rewrite it in exponential form by taking b to the x equaling y. So b to the x equals y. So we're going to practice going back and forth from log to exponent form. Okay, so let's say I gave you something like log 2 of 8 equals 3. Okay, so this is pronounced, again, like if I were to say this, you would say this log base 2 of 8 equals 3. That's how you would pronounce that, okay? Well, log base 2 of 8 equals 3, if I wanted to write that in exponent form, in my head, I kind of say, okay, well, that's base to the other side equals what was inside the log. So 2 to the third equals 8. And when you rewrite it in exponent form, it should make a true equation. Is 2 to the third power 8? Yes. So 2 to the third equals 8. Okay, if I want to put it back into log form, so let's say I have 4 to the 0 equals 1, right? Anything to the 0 power is 1. Okay, I'm going to put this back in log, whatever the base was in your exponential form, so here my base is 4, that goes back in as 4. So log base 4 of the other side, which is 1, and it always equals your exponent. So whatever your exponent is, that's what your log equation should equal. Okay, and if I were to convert this back, if I wanted to, make sure it was done correct, I would say, okay, well, this is base to the other side equals what's inside. So is 4 to the 0 equal 1? Yes, that's what I had. Okay, so let's look at log base 12 of 12 equaling 1. Okay, so if I want to put it back in exponential form, this is base to the other side. So 12 to the first equals 12. Base to the other side equals what's inside. Okay, let's see, 1/4 to the negative 1 equals 4. Okay, so we are going to start getting, fractional values, negative exponents, and that's fine. So I'm just going to rewrite this in log form. So log with the base, whatever base was in my exponent, I'm going to use it here. So log base 1/4 of the other side, which is 4, equals the exponent, which is negative 1. Right? So if I were to rewrite this in exponent form, let's just double check. Is 1/4 to the negative first equaling 4? Yes, 1/4 to the negative first equals 4. Okay, log base 1/2 of 32 equals negative 5. So if I want to put it back in exponent form, 1/2 to the negative fifth, so base to the other side, 1/2 to the negative fifth, that equals 32. Base to the other side equals exponent. Okay, and my last example here, if I'm going to rewrite it, if I have 3 to the 4th equals 81, okay, again, I'm going to write that as log with the base of my exponent, so the base is 3, of the other side, which is 81, equals the exponent, 4. Okay, so 3 to the 4th equals 81, which is what I had. Right? So, just make sure when you are rewriting it that what your log equals is the exponent. The base of the log should be the base of your exponential equation, and what that number equals is what goes inside the log. Okay? So if I ask you to evaluate logs, that's where you want to use your powers table. Okay, so if I said evaluate these logs, what you are doing is you're asking yourself what power of b gives you y, or what power of the base gives you the number inside. Because basically what I'm asking you, right, like in number 7, if I said what's log 4 of 64, if I rewrite this in exponential form like I did up here, I'm asking you to say, well, 4 to what power equals 64? Okay, well, let's see, 4 to what power is 64? Well, there's 64. 4 to the 3rd power is 64. So my answer is 3. Log 4 of 64 is 3. Because if I were to rewrite it, 4 to the 3rd equals 64. Okay? If I said, well, what's log 2 of 1 over 16? Again, if I said, what is that? You are saying, okay, base to some power, so 2 to what power gives you 1 over 16? Now, a couple of things with this problem, right? As soon as you start to notice that you have a whole number that has been turned into a fraction, what that means is the exponent here must have been negative, because remember, negative exponents move your numbers to the top or the bottom. So I know this is going to be a negative number, and then I'm going to say, okay, well, 2 to what power gives me 16? So let's see, on my powers table, here's 2. 16 is in the x to the 4th column, so 2 to the 4th is 16. So my answer here is negative 4, because if I wrote this as log base 2 of 1 over 16 equals negative 4, right? This would be like saying 2 to the negative 4th power equals 1 over 16. 2 to the negative 4th, I would flip that, right, to make that 1 over 2 to the 4th, oops, 2 to the 4th power, and then 2 to the 4th power is 16. Okay, so that's why those negative exponents change your whole number to a fraction. Or in number 9, it could go the opposite. So if I said log base 1/3 of 27, what does that equal? Well, I'm asking 1/3 to some power gives you 27. Okay, well here I'm starting with a fraction and it's ending up as a whole number. So I need a negative exponent to like flip that fraction back upside down, so 3 is now in the numerator. So I know my answer is going to be negative, okay? And then I'll kind of look and say, okay, well 3, how do I get it to become a 27? I need it to go to the 3rd power, so my answer is negative 3. Because 1/3 to the negative 3rd power, if I was following my exponent rules, I would flip 1 over 3 to become just 3. My exponent would change to a positive 3, and 3 to the 3rd is 27. Okay, let's look at a couple more. Okay, so let's evaluate here. If I had log 7 of 1, okay, so I'm asking, again, 7 to what power equals 1? Well, anything to the 0 power will always give you 1. So my answer is 0. Log 5 of 5. Okay, so again, I'm saying, well, 5 to what power gives you 5? Well, to get 5 back from 5, my exponent must have been 1, because 5 to the 1st power is 5. Okay. Log 36 of 6. Okay, so this one is saying 36 to some power gives you a 6. Well, how are you going to go from 36 back down to 6? Well, how are 36 and 6 related? So if you think about it, 6 is the square root of 36. I can't write square root here, but I can use an exponent that means square roots. So what I want you to remember is back a couple of weeks ago, we did some video lessons on rational exponents, right? So remember, if you have something like a to the 1 over n, that's the same thing as the nth root of a, right? So if I want to take the square root of 36, well, that's the same as saying 36 to the 1/2 power, Okay, so we're going to start to use those fractional exponents again. So 36 to what power gives you 6? Your answer is 1/2. Okay, so I would kind of write this as, log 36 of 6 equals 1/2, because 36 to the 1/2 power is really saying the square root of 36, and that gives you 6. All right, let's look at the next one, log base 2 of 128. All right, so again, I'm saying 2 to what power gives you 1 over 128. Oops, 128. Okay. Well, again, I'm going from a whole number to a fraction. So I've got to have a negative number to make that flip happen. And then let's see, 128. Okay, if I'm looking at my powers table, that only goes up to 64. But 64 times 2 is 128. So I'm thinking it might be like if I had an x to the 7th column. So let's just double check. If I did 2 to the 7th power, yep, there's 128. So my answer is -7. Because 2 to the -7th power would flip. I kind of do that over here just to make sure you guys are good with this. 2 to the -7th power, that would become 1 over 2 to the 7th. And 2 to the 7th would turn into the 128. Okay? Log 32 of 2. Okay. So again, I'm asking 32 to what power gives you 2? Well, this is very similar to number 12, where like I have a big number going down to a small number. So that must mean 2 is a root of 32. So 32 to some power, like if I take a root of 32 and get 2, so let's look at our table of powers. So here's 2. If I kind of scan over, 32 is in the x to the 5th column. So the 5th root of 32 is 2. And what exponent represents a 5th root? Well, that's 1 over 5. So my answer here is 1/5, because 1/5 is really like saying the 5th root of 32, which is 2. Okay, so 32 to the 1/5 power is 2. Okay. All right, and we'll look at the last one in this little group. Log 8 of 8 to the 4th. What does that equal? Well, again, I'm saying, okay, 8 to what power equals 8 to the 4th. So can you see you're just matching up? You have an 8 and an 8. So the question mark matches up where the 4 is. So 8 to what power is 8 to the 4th? Well, that's just 4. That's kind of getting into a little bit of solving that we're going to also do next week. Okay, so just be careful when you're going from a bigger number down to a smaller number. That's when you want to have a fraction, because you're taking a root. And when you're going from a whole number to a fraction, or a fraction to a whole number, you will have a negative with your answer. So there's 2 special types of logs that I just want to go over with you real quick. All right, they're called the common logarithm and the natural logarithm. So a common logarithm is a logarithm with a base of 10. So that might look something like this. Log base 10 of x. Now, because this is a common logarithm and it's a special log, you actually don't write the 10 there. So if you ever look at a problem where you don't see a base, that's going to be 10. So when I say simplified notation, this is how it's going to look when you look at problems. All right, so log of x, you would interpret that as log 10 of x. So if you don't see a base, it's 10. Now the natural logarithm, this is going to look familiar from your last video. That's a log with a base e. So that would look something like log base e of x. Well, again, a natural logarithm, it's one of these special logs. We have a simplified notation for it. So you're not going to see it written as log base e of x. You're going to see it written as ln of x. And if you remember, when we were accessing that the e key last video, when I would do second ln, do you see how e to the x is with the ln column, ln button? That's because those guys match. They just go together. And if you look right above it, do you see 10 to the x? That's the log key. So you're going to see these guys are going to help us solve some equations next week. But log of x means your base is 10. ln of x means your base is e. So if I wanted to evaluate some of the common logs, right? If I just said what's log of 1,000, well, there's no base there. So you have to remember that that means this is really log 10 of 1,000. So if I wanted to know what is log 10 of 1,000, well, that's just saying 10 to what power gives you 1,000. Okay, and let's see, 10 to what power is 1,000? Well, that's the power of 3. So my answer here is 3. Okay, ln e to the 7th. So if I said what is ln e to the 7th? Well, if you know, ln is just log with a base e of e to the 7th. So if I rewrite that in exponent form, e to what power is e to the 7th? Well, just match up the question marks. E and E, so the question mark has to be 7. Okay, because e to the 7th power is e to the 7th power. Okay, look at this last one here. Log of 1 over 10,000. So that's really log with a base 10 of 1 over 10,000. So what does that equal? Well, that's like saying 10 to what power is 1 over 10,000, okay? Well, I have a whole number going to a fraction, so that's got to be a negative exponent. 10 to what power is 10,000? That's the power of 4. So my answer is negative 4 because 10 to the negative 4th would flip it to become 1 over 10 to the 4th, and 10 to the 4th is 10,000, all right? So, you know, just be careful with your exponents, fractional and negative exponents, okay? You could have a combination of both, so I'm going to add one extra problem in here. Let's say I did log 81 of 1 over 9, and I wanted to know what that was. Okay, so this is just kind of showing you we can have a combination of everything. So here I'm saying, okay, 81 to what power is 1 over 9? All right, well, I've got two things going on here. 81 is turning into a fraction, so my exponent is negative. But 81 is also going down to a 9, which means I would have taken the square root of 81 to go down to a 9. So the square root of 81 is 2, and a fraction of 1/2 means a square root. Okay, so here I have a negative and a fraction because 81 turned to a fraction and 81 went down to 9. So 81 to the negative 1/2 is like saying flip it and make it 1 over 81 to the 1/2. And then 81 to the 1/2 is really the square root of 81, which is 1 over 9. Okay, so this is just kind of like an extra problem to show you that you might have problems that incorporate the negative and the exponent. Okay, so this is all kind of the work that I want to see when you are doing your logarithm practice, all right, on Schoology.